Alrighty. So if all goes well, I am streaming. And it does appear that I am. So got chat open, as I'm wont to do. As usual, I'm going to shuffle around the windows a wee tiny bit. And hi there. I am Chris from Airwindows, and we're going to do another coding stream. Hey, Alex. And as such, I am going to switch right over, juggling my multiple mice and computers, to coding mode. So where did we leave off? Well, we left off with me having released Wait and coding a subsonic kick drum emulation thingy plugin that I invented. And we're picking up with me just having released Console 8 Lite, and I put some extra effort into the video for that. That was kind of fun. And I'm returning to the what I'm calling Orbit Kick. As you can see, I have several, more than several plugins that are underway. We've got C-Strip 2, PAF92, Sample Delay, all of which are stuff to bring over from either earlier versions to make into a format where I can use them in VCV Rack, or just stuff that has not come out yet. Excuse me. What I have up on the screen is something different. That is, well, I'll show you. Suppose we have drum kit. There's a drum kit. Hey, Lorenzo. If we use this newest plugin, I'm working on a new form of algorithm for distorting with. My apologies, as that was quite loud. Can I make it quieter? Yes, I can. So I don't remember how many of these parameters are actually still functioning on this, but the idea for this one is twofold. And that's a lot of gain, I know. Actually, I can turn it down. I know that that is a gain control. I have a great deal of gain on tap, so we can distort really, really hard. That's just one stage, but the purpose of this one is to try to come up with a gain algorithm that acts like a sine, but is much quicker to compute, because a sine is a complicated math function that's on the tricky side, and there were some things I wanted to experiment with, and I'm not going to worry about that right at the moment. I'm going to dive back into Orbit Kick because I have some things I want to do there. And I'm only going to take a couple hours. I kind of promise I'm not going to go 3 or 4 hours today. But the purpose with Big Fast Sine was to come up with a sort of fatter, more gain-oriented form of a sine that was a linear function, so there are no little arbitrary points where the transfer function makes abrupt changes. It should all be pretty much the same. but I'm also trying to do a function like that where it applies as few mathematical calculations as possible, and as many of them are shifting bits, which is lossless. Like with the plugin that I'm never able to say out loud, unfortunately, on YouTube because they think I'm saying a naughty word, bit shift gain. And that being the perfect gain function for either linear math or floating point math, because if it's floating point math, all you've done is you've changed one of the bits of the exponent, but you have not touched the mantissa. That being the part that can degrade on you and give you quantization noise. So that type of gain shift is always perfect unless you're either distorting or losing data out at the bottom. Anything between those things, you can do that back and forth all day long and it will never change. And it will never sound any worse. I apply that function where convenient, and I'm trying to do the math gain. I'm trying to do the sine-like function that does as many calculations as possible, kind of like that. So it does the minimal things it can do while still applying the saturation. And you just heard an example of that. My hope is that, and thanks to using the online website for Wolfram Mathematica, you can do things like have a function that distorts and ask it, like, what would I need to apply to undistort this and give me the input back? Much like the console plugins use sine and then arcsine to apply a really good smooth distortion function, and also the exact opposite, and that's how the console system works. So I was actually able to do that. I got back and you might have actually been hearing that in that example. I got back a calculation where I will be able to do a console version based on this new thing that I'm calling big fast sine. But for now, let's jump into OrbitKick again and refamiliarize ourselves with what's going on. We've used a bunch of controls and they are all rather tricky. And since I haven't recompiled it, I can launch this. I think I was using DrumKit Mono to actuate it, because if it was in stereo, it was not actually giving me a stereo output, and it still isn't. So apparently, I wonder whether I can change that. Apparently my HDMI output is 2 outputs, but I'm only getting 1. So let's take a moment and see whether I can make that. I think I'll hear it if I'm able to fix it. I may or may not be able to fix it on the fly. Let's see what we have here. I'm pleased to hear that Lorenzo has found a good combination. Indeed. Good combinations are good. Let's see what we've got. USB digital audio. That is what it's supposed to be. Advanced audio properties. We're monitoring it correctly, but let's look at the setup. Okay. So that's weird, but I'll live with it. Apparently my HDMI output off of the laptop I'm coding with is sending 2 channels of output, but the converter that is putting it on my screen is only giving me 1. That is sadness, but oh well. Unless, let's see if we just killed it. Aggregate device. Don't mind me fooling with the controls. It is sometimes the way of it. Primary and front left. I'm getting 16 bits of input. Let's see, can we still hear this, or have I made it go away? Nope. Okay, so we can't actually demo stereo in these coding streams. That's weird, but okay. Console plugins need to have unity gain between the channel and bus plugin. That's the only one that I would say counts as that. There's a kajillion other plugins. They don't all have to run at unity gain. And when 0dBFS is a metering volume, it means that a signal is expected to be at full crank. That's not necessarily the case. When I say unity gain, what I mean is you don't touch the faders between the console plugin and the bus plugin to use a version of Airwindows console. The sounds may not be anywhere near 0dBFS. They could be much quieter than that. To tape bump, so you're talking about and so as in literally just tape, okay. Yeah, what you're discovering is that I have the ability to add like deepness and weight through the head bump. And what you're doing is you're simply distorting the end result of that in such a way that your head bump is now a little extra saturated. So what you're doing is you're taking a low frequency that's being added, kind of synthesized like the tape does, and then you are adding a level of distortion on top of that. That's what you're hearing. So it's bringing the low frequency rise up very slightly without adding any more low frequency boost. And yeah, it would be similar to if you had the low frequency boost in front of the saturation, or between two saturation stages is another possibility. So having figured out that my input is going to be mono and that limits our ability to do stereo stuff, well, there's actually one thing that I could do, which is if I was running stereo through the studio, as you heard on the Console 8 Lite video, that is demonstrating something that I'll be able to do in future, or if I start sharing music creation jam days, where I can run the output of the entire studio both into my recapture for working with in the studio, but I'm also separately running another set of analog outputs into a converter that runs into the streaming laptop. So I'd be able to get stereo out of that quite easily, but it would have to run through the whole system. Anywho, since we're working on a mono sound anyhow, and I can probably always come up with stuff to do that isn't stereo, so I'm not really worried about that. Here's where we left off. We have an input sound, and then we have a electronic kick generator, and it's getting triggered by sounds coming in, and then it is decaying, and these are the tweaks I have for it. It's all very delicate. This is just how I got the rough outline. And so one thing I can do if this stays, which it will not, is start making notes on what this stuff actually means. My poor little laptop will be overheating quite a lot as a result of that, but that's fine. spaces. Because here's the kind of thing that I can do is write down what I've got there, and then I'm going to be trying to work out both what controls I'll want for the final output and how to scale them in such a way where all of the settings work. It's a very key thing doing this kind of thing. One of the things I'll probably want to do is make it so it's a dry, both, wet control. It's a little similar to what panlaw is, in that the way I use this one, I'll probably want to be able to have it full dry, and then as you go to halfway, you'll be able to add the synthetic sound without turning down the main sound. And this is something I do in a bunch of reverb plugins. And then there is our end result. So decay 0.126. Gain 0.01, or it will distort very, very heavily. Friction is 0.221. Because this is me finding the zones for within which this stuff works. Envelope 0.035. Threshold is interesting. Threshold is 0.047. Onset frequency 0.68. And that is giving me a kick drum that is, we have a variety of things going on here. Like one of the things I was working with when making this, hey Shankix, one of the things I was working with while making this was I can make a sine that just drops in frequency, and that's in fact what I'm doing. I'm using a technique that is similar to what's called a random walk, where if you want to make a noise source that just expands down into low frequencies rather than being simply white noise, you do a random walk. And that expands down pretty much infinitely into low frequencies, and that the lower you go, the louder it is. A regular white noise is going to be, here, let me, I'll periodically step away from that. Regular white noise is just like, give me a random number. And it's really bright sounding, like tsh. Whereas if you want a thundery noise or a ambient acoustic noise, and I do this in Voice of the Starship, the plugin that's all about making deep, low frequency noise sounds. And it's done through variations on taking a random noise and adding it or subtracting it from a variable. If you do that, theoretically, the average of all the random pluses and minuses that you add might wind up being around 0, but it could just as easily be wandering off in a direction. If it's wandering off in a direction, the noise you've created is random walk, meaning that you just added a bunch of DC voltage. And what I'm doing with the way that this stuff works, this orbit kick, this low frequency generator, is I am adding, and I can probably remove some of these now. I was staying focused on the fact that I was going to model an actual circle in this way, and that's no longer really very relevant to what we're doing because I'm not actually measuring that ever. It will still work if I do this. I have just not done that thing. So we have speed equals input sample here. Here's the total width of all of our text. Speed equals input sample times onset freak. So onset freak will determine how high in pitch our sound is able to go. This thing with position there is simply going to make sure that our sine always, we're just using sine to generate a thing. And this is meant to be able to go up to a very high value. It doesn't have to have anything to do with, like it could just easily be that. And if it goes to that, it goes to 0. Or we could calculate something. Do I have a sine variable here anywhere? See, synthesis based on a sine function. I don't know if I have a variable here. Oh, I have a calculator that can give me kind of what I need. But I can also do this. So in this way, if the position goes beyond a full circle, then it will return to 0, and it should be the same place on the circle where it will not make a click. On the other hand, if I had it be if position is larger than 1.57, go to 0, then the position factor and what it produces from this algorithm, there will be a place where there's a sine factor going up and down, and it will go to max and then flip over to the other side. That will make a discontinuity. Thing is, since we are doing this thing with position, it doesn't have to be 3.14. It could be 314. I'm pretty sure that will still give us, it will go from one point on the cycling of the sine function to the same point. It will go from 0 to 0. Or we can go to a very, 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 very high number indeed. And that should still, because we're multiplying this by 10, I'm pretty sure the way this will work is that if you're cycling at 3.1415, etc., that's one cycle. But the thing with the sine function is you can keep going. You can do the sine of like 27 and a half, and it'll give you the correct thing. And for that reason, I'm interested in using a larger number than just 3.1415, because I feel like that might be able to give me a smoother interpolation through this cycle. And very rarely it will get to the point where it's like, okay, that's exactly 1,000 loops. We go back to 0 and then continue. Oh, Erwin, MH, you are going to have to wait for me and Paul to work on that a little bit more. I have a question. Does anybody know if I can use Airwindows plugins in CLAP format on Windows? Reaper doesn't detect them. That'd be because the only ones I've posted are Mac, I think it's Mac M1 binaries only. And I don't have Intel for Mac yet, and I don't have any of the other formats because I was only able to compile it on my own machine. Paul knows how to compile it on GitHub itself and apparently has all kinds of scripts going, and that is why the VCV Rack plugin is available for all these different formats, whereas my attempts at doing those things don't do that. So you need to wait for me and Paul. It's mostly going to be Paul. I don't want to bug him, but I will ask I'll ask for you. When he can set up the same kind of script function that he has on the rack plugin to also exist for the clap plugin, at which point I'll be pointing people to a directory on a GitHub repository of his, and that will have the dailies for everything. And it will not only build you a Windows binary in clap and in Linux and all that kind of stuff, but it will also rebuild with the new plugins that come out every time he hits the please build this button. And the reason you can't use it yet is because we don't have that going yet. So I'll ask him. And yeah, the sign function does a complete cycle every 2 pi. Yeah, basically that is, the thing is that the sign function will continue to do the complete cycle as you keep adding higher and higher numbers. So rather than like block it off, I mean, I'm assuming that it's a reasonably efficient way of going about it, and I'm not making a terrible... I suppose I can find out by finding out whether it starts eating up all of my CPU, but I don't think that's going to happen. I think I can just do it this way, and it'll work out just fine. And the reason for choosing the much higher number is so that the sign function will kind of continue processing higher and higher numbers smoothly rather than ever hitting this point where I'm updating it. Because the thing is, to update it correctly, I need to not reset it to 0. What I need to do is subtract what there was, and then I can't do the 2-stage if statement. Because what I've got it doing is if position somehow winds up being a negative number, it will update that as well. Not that sign would break if you... Okay, let's do something. It's not an important thing, but it's a something. We're starting position at 0. This is just an insanity check to see if it's ever horribly broken. And for no reason, position is a super negative number. But the thing is, if you feed a negative number to the sign function, it'll still work. So I did this, but there's no special reason that I should have. It was an oversight. I didn't realize, oh yeah, I never need to check for that because it will never matter. So let's take that away. And then the thing I was telling you about, if the position is larger than 3.14 or whatever, and you're going to do the wraparound, well, you don't necessarily want to reset it to 0 unless it stopped at exactly 0 and updated to the point where it was exactly this other number. You want to subtract what was in here. So we're going to try that. And it starts at 0. And then if it is larger than this, it gets subtracted by that much. And that means as you pass through the 0 point, it will flip down to near 0, but it will be in the same place in the sign algorithm that it was over in the... Let's find out if this works. And again, that is a thing where it's perhaps somewhat arbitrary. But I'm trying to watch for weird little details where you've got a idiosyncratic incongruity and your algorithm is making there be a tiny discontinuity somewhere on a curve, somewhere on an audio part. We're trying to take away the capacity for that ever to happen. Having done that, we're going to find out whether it actually works at all or whether I just broke it permanently, which is not likely, but we'll find out. So back to our drum kit and back to our synthetic kick drum. I'm going to say that sounds like it works. But the point being, it is similar to when you have, for instance, let's fool with this a little bit. Oh, took that too far. I'm picking a lower frequency so I can talk over it without it interfering. If I have onset freq be high, we'll get high pitch noises. There's actually a lot going on in here. We will dive into it as we see fit. But the point being, here's why one does this bit. If you had it so that it was like if position is larger than, you were saying 2 pi, that'd be like 6.28, etc. Let's say that's true. So if you're repeating the sign and going through to 6.28, etc., etc., that point, oh, is it loud? Okay. I will be turning that stuff down when I work with it again. As you are going around this circle caused by the sine, and you're going past the 6.28, etc., if you go, if position is larger than 6.28, etc., position equals 0, what's going to happen is, supposing you're going really fast, right? And it's going so fast that the next time you check, it's 6.45. It's way past 6.28. So you reset it. You go to 0. Guess what? We just made a discontinuity in the output of the algorithm, because the algorithm didn't just stop at that point where it's like, yeah, you need to reset when you hit 6.28, etc. Instead, it's only seeing it's like, I don't know, quantum physics stuff where you're measuring the granularity of time. And as a result, your output wave is spinning around this circle, and you want it to spin smoothly and fluidly without any discontinuities. Then if you update by going, if you're beyond the point where we have to loop back, you loop back to 0, you're skipping back slightly. It's going to overshoot a little bit and then be reset. That overshoot and reset causes a sound. There's a faint high frequency tick, and our ears are very sensitive to that stuff. That's why we are bothered by, those of us that are bothered by quantization noise, is it's like little high frequency sounds. In particular, quantization noise is annoying on low frequencies because at the tops of those waveforms, that's where the quantization noise kicks in more intermittently. Like as it's going over the top of a really low frequency waveform, the quantization will make little ticks. And if you are going at a high frequency waveform, the little ticks are happening so fast that they kind of blur out. But it's the same deal with this, and that's why I've updated this code to say position minus equals. And it could be basically any number. It doesn't have to be just a pi related number. And it's a much higher number than just pi because I want it to go extensively and then reset. But doing that subtraction means that we never actually go all the way back to 0 again. We're always going back to the same place on the algorithm of the sine function that is causing the sound to happen. So there's never a little discontinuity where you go all the way up to here and then boop, snap back to 0 again. It will snap back to close enough to 0 where you're back at the same point of the cycle. So let's look into some of this stuff while we're at it. One of the things I can do is delete those. I'm going to get more of this to show on the screen. So one of the things I was doing with the big fast sine calculation was get it to take up very little space on the screen so I could see the whole chunk of it. Here's a thing where I don't actually have to have this bit. If you only have one statement, you don't have to put the brackets in. And I often like to do that. This is not necessarily good programmer form, but I'm just like figuring out where I stand with this anyhow. So I'm going to run it all together and then space it out again when I am done. And we don't need orbit y for anything, so I'll take that out. In fact, let's rename everything from orbit x and orbit y to just orbit. There it is up there. Here's another couple of examples of it. And now I got to go to the header file and find where my variables are, which shouldn't be too difficult. And this one we are simply not using ever. And this one we have renamed. And if we rebuild this, it should still work. Yep. So I'm going to take that as read that I did that correctly. Hey Mel, I'm glad you like it. Console 8 Lite. I'm happy with it because I was never that much of a fan of using the multiple bus configurations. This in spite of the fact that the analog is actually using a Console 8-like topology. Go figure. But I like having the DOS stuff be a little bit simpler sometimes. In fact, if that had a simpler topology, I'd probably be happier with it. The reason it's not is for noise floor and performance issues. It's the Heritage, at my understanding, uses a combination of topologies. Like one way they can sum things is one way that a mixer can sum things is with a just resistive topology where all the voltages go into something with a resistance mixing and then you amplify that up with something where you're going into the positive side of an op amp or whatever. That produces the console style of distortion, because if you have lots of stuff in the negative swing of their outputs, they're going to be tending to pull a positive voltage source more easily into distortion because the input impedance of the bus has been fluctuating. Whereas if you have a floating ground summing bus, that is like an op amp, which is a little more, that's beyond your early 60s mixers and stuff. That's into your 70s and 80s mixers where they needed to add lots and lots and lots of stuff. So they had to start using different techniques. And running into the negative input of an op amp and then just flipping the phase at some point means that all of the inputs feeding into the bus are getting resisted by the negative feedback in the bus, so they can never look at a fluctuating input impedance of the bus because the input impedance of the bus is always held rigorously to 0. I'm pretty sure the Heritage Audio sums the banks, like the first 8 and then the 9 to 16, with the floating ground bus, but then just additively sums the submixes to the final output bus. I'm pretty sure that's what that is. I'm wondering about a side. Well, I don't have sidechain facilities. I do not have sidechain facilities, and that's why that isn't there. Now, as far as a filter is concerned, I've been asked for something like that. A fellow who builds Oratone-like speakers, or at least, Karloff 70 builds Oratone-style speakers, asked me specifically for a version of Purist Squish where it had a high-pass filter on the sidechain that could go up super high, which is an unusual enough request that I'm kind of like, oh, okay, maybe I'll see whether I can do that at some point. If I do, I might very well be doing it on a coding stream. It's not happening today. But yeah, I don't always put sidechain filters into compressors. That's like, not everything has all of the features all at the same time. Speaking of all the features, let's get back into this. So, increment is 1 minus a very, very small amount. So, get param 1, comma 2, so that's 0.126 times itself. So that's going to be 0.0 something. And then times 0.001, making it even smaller. Increment is how fast the decay of this goes. So it's probably worth experimenting around a little bit and finding out what kind of range I'm going to want. Purist, all of these are digital comps. They're all plugins. Purist Squish is, in fact, a compressor where I'm not entirely sure why I ended up calling it Purist Squish, other than that I was making plugins with that trope for a while. I did a variety of things. I even have a Purist clip, which I do not remember what I was trying to do with it. Something was going on there. Maybe I was trying to do what I'm now doing with Big Fast Sine. I'm not sure. Music Anywhere is enjoying Console 8 Lite. I'm glad to hear it. Very cool. Yeah, and don't fret about donating to the Patreon. I've been saying this entire time, but even before I had the Patreon, I was selling plugins for $50 a pop off of Kagi before Kagi went out of business, owing me money. And when people would ask me, which plugins should I buy to be good? Back when I was selling on Kagi and didn't have any shareware or freeware, and it was all honor system, buying individual stuff using a digital download system, which is what I used to do. When people would ask me, which plugins should I buy? I would try to find out what they were trying to do, and if they didn't know what they were doing, I would steer them towards the freebies that I had, even in those days. And I would say, here's the collection of freebies. Use all of these until you know what you want. Do not ask me what you want. If you need to ask me what you should buy from me in order to do a thing, that is not the kind of interaction I want to have, and so that's what my freebies are for. Well, now they're all freebies, and they're all Patreon supported. And so, yeah, like, take care of yourself first. I've always kind of rolled that way. The only thing I will say to add to that is I have been taking steps to be ready for a particular thing. Like, remember when I promised I would do the ASR 10? I was talking about samplers, and I don't use samplers in my music, so that's challenging. That's always been kind of challenging, because I had my eye on a now that I'm just talking again. I had my eye on a famous old sampler. I had my eye on what the hell is the thing? The EMU SB1200, or possibly SB12. But this is like a antique 12-bit sampler with analog output stages, analog output filters, and the SB1200 is like old school hip hop, classic. Trouble is, that's like $8,000. I did not get to the point where I was going to be able to just randomly get that, and more relevantly, it would only be to study, because I don't make sample-based music. The stuff that I do is based off of like a analog mixing board and like a analog tape machine. That might be a more relevant question, like save up to get a Studer 2-track or some kind of like an MCI, it's 24-track, just so that you can have it. And that would be really, that's really challenging, because here's the thing about that is rolls of tape are kind of expensive. Working in digital stuff has some advantages as far as you can do an album without dropping thousands of dollars on tape. And in fact, you can do an album. Back in the day, they were doing stuff like that with Radar. Radar was a classic. That was the digital audio workstation for people who were used to what like 24-track tape sounded like, and were determined to stick to what they had back in the day, and not like they would be looking at digital and be deeply unhappy with what they got out of that stuff. So they would go and get Radar. And it would have better converters than was easily available in the day. And it would also be set up to work more like a classic tape machine. Well, these days what you can do is have your analog console and then use a simple sort of, I would almost call it prosumer. You can balance between the two things. Like I demonstrated this in the Console 8 Lite. You can use a Motu for the multi-channel stuff. You don't have to have 16 channels of input and output in Lavry. That would be impossibly expensive. You don't have to have 16 channels input and output of like Burl. Burl is another example of a really fancy pants converter, and the sort of thing where this is something I was talking about at the end of the video. I mentioned you should be able to get one sound and mix it with like two other sounds and have a track that sounds awesome and huge. And I can support that with Console. Console 8 Lite supports that. I demonstrated that it does. It got really close to the analog hardware, which itself, this analog hardware is nicer than any previous mixing board I've had. I've had sort of smaller live style mixing boards. I've had an Allen and Heath. I've played with a Roland line mixer, stuff like that. And the Heritage Audio, with the limitations that it has, is more or less on par with what I would consider top of the line, because I'm not really looking for, you know, EQs and mic pre's and all of that built into the thing. I'm looking for the summing part of it, and I want it to act like a mixing board. Mel, you shouldn't go anywhere yet until you work out what you're doing. So the deal with the multi-channel stuff is you can get something like a Motu and have it be similarly stripped down. Like I'm happy with the 16A. I did a video where I compared the inputs of the 16A with literally the inputs of Lavry. And it wasn't exactly the same, but it wasn't wildly off the mark. It wasn't like, you know, Behringer grade. Excuse me. I'll probably have to cut off before 3 hours today, because I gotta, rest up. Winter is dragging on, and trying to make sure I'm still healthy. I do not know how to make all the console 8 sliders in one window for easier adjusting of levels, but you know who does? Bacon Paul. So if you get a mixing board plugin, and I've talked with him about this, like if I can give him a block diagram of which plugins need to go where and what bus depths need to be at what place on the circuit being program, then he can make that probably fairly easily. So it's not possible for me to make that plugin. However, it is possible for Paul to make that plugin, and if he is putting things together in the way that I'm saying is put together, then it'll be a full-on like console 8 sounding thing. Like I can define what will make it sound absolutely as good as anything that I've got, and what would have it be not sounding it. And I probably don't need to do unreasonable things like have the internals of the bus be running in long double or something like that. I mean, I could, but I would know that it was superfluous. I've already made those experiments, so I don't need to go to long double, but I can tell Paul where stuff goes, and I can't put the pieces together, but he can. So we'll see. Music Anywhere. I'm glad that the streamlined way the plugins work helps you. I do it like that on purpose, and there's always a balance in there. Like some of the folks in the Surge Synthesizer forum are interesting because you run into them, and they're always looking for the next feature. They're always looking for something new to do, or like, well, you could also have it do this, and you could also have it do that. And part of design is choosing which stuff it doesn't do. And that's what we're going to be doing with Orbit Kick, which I'm still working on. So, where did we leave off? Let's do something. Let's change how increment works. 0 plus so 1 plus get parameter kparam1 times 0.01. That's going to be too much, so I'm going to add another 0. I already know it's going to be too much. And there's also going to be a minimum increment, and I'm going to be looking for that. This is eventually going to be like a 0.0001 in there, but not just yet. I want to hear what that sounds like. And the way this is going to work is the closer it gets to the 0 position, well, let's just find out. Speed is being cut down. Some of this is redundant. I don't need to do all of these this way. For instance, onset freak. If onset freak is 1/10 of how big it is, meaning that it will, when we are updating this stuff and the input sample, see, here's how I'm working this out. This is a sort of delicate balance, the way this is working out. It's not really that hard, but I just goozle myself as far as figuring out what's going on and where. And we haven't even included overall skill yet, so that's going to be a thing too. we've got if input sample is larger than speed, which is our decay. So let's put this back, because I confused myself for no good reason. This is what we previously had. Thing is, we are making position equals speed times 0.1. That's just me trying to make it not be too high frequency. If I take this away, I'll show you what happens. And I like having these be simple, but I included that for a reason. Let's build that. And I'm assuming audio input capture isn't literally distorting, but I might need to. Let's just pad it. So input sample equals input sample times wet, but we're no longer having dry, so I can attenuate it like that. That'll make it not be too loud for you, and it won't hurt your ears or your... One thing I was discovering is that when I played some of the last stream back on my big system, it was just making my subwoofers rumble overwhelmingly. It was too loud, so I agree that it is too loud. And I will fix it thusly. But the too loudiness is going to be a different thing this time, because I've just taken speed and I'm no longer dividing it by 10. So what we get is it's a higher frequency now. A super high frequency. Hey Oro Music, thank you so much. Somebody else showing up and saying hello. So this is supposed to be a drum, a kick drum. But while we're doing this, let's also find out what decay is doing, because we did change decay. So we can make it drop down, and because of the way we're doing it, we have a contour here. And I think we can still drop onset frequency down to a basic frequency. But something's happening here that wasn't what it was before. We're now getting a scruff on the onset of the noise. See, we're hearing the sounds. Although if we turn threshold up, we can block it to some extent. If we turn threshold all the way down, we're hearing nothing but raw noise. See, it's triggering it. Or even giving us weird things like this. See? So what we got here is a very slow decay, but when we have a track, a sound that is not kicking off a new waveform, it's very easy to get it to where it's re-triggering a lot. And that's different from what I had before. And this goes from 0, no decay, to like around 0.2, which might be a good place to start for having it fall off. In fact, let's go and do that. Remember how we had this? Oh, but here's another thing. So if it's 002, then we're going to have this. We're going to start at an increment there, but then multiply that by 002. We're going to multiply that by this. Because we're making it so that the lowest frequency still has some decay. Like you hear, it'll fall off a little bit. And I know why some of this is doing what it is, but more on that later. So if it was 0, 1, we would add 1 0. If it was 0, 1, we'd add another 0. And if it's 0, 2, well, hey, we're now starting at this point when we've got the thing set to 0. Now, what else have we got? We have it falling off. But here's the thing. We can start with this and know that we'll always have a minimum fall off. It will never be just fall on. We can have the maximum be 1.0. That's giving us a really fast decay. And so that is a fall off. These other controls are also going to require some attention too. So here's something that I had not yet done. But might be worth doing. Speed divided by increment is giving us our taper. We might want a taper factor in here as well. In fact, it might be a better purpose for increment. So here's what we're going to do. We are going to build in another one of our dry-wet controls, but one of those ones, like off of our other plugins. Let me try to remember one of the ones which fits this description. I know I've had this working in fairly recent stuff. So Time to go and find one. What have I put up recently? Hey, Eldot. Well, thank you. I'm going to try to measure my Mackie 1202 mixer and put some effort into trying to do a console version, which will be the first letter console version. And it'll be console M for Mackie, and use the Mackie plugins as the baseline for a version of console that works and sums like the actual Mackie 1202, except for you can have all the channels you want in any combination of EQ'd or not EQ'd. I have that in mind. It is not happening today, but I will be working on that. So let's see, what was I trying to find out? I was looking for something where I had the multiple stages of dry wet along the lines of recent plugins that I've posted, which I don't remember which one it was. So let's start scrolling through all of these and seeing what's there. It's overwhelming. I know it's not a reverb. Let's look, I think it's Holt. I think I had Holt 2 doing that. So let's go and find Holt. GH. Holt 2. And if I'm not mistaken, I had simplified weight. But I think it still does that, but it's buried within the algorithm. Let's see whether I've got what I'm looking for in literally the weight plugin. Signs point to no. I had removed that from weight, but I think it's still in Holt 2. I'll show you what I'm talking about soon. Holt 2 definitely has this, unless I'm mistaken. We'll find out really soon. Oh, I know it. There we go. See, this is what I was looking for. I'm going to grab this chunk of code, simplify it, and apply it. First, let's kick this over here. Let's kick this down here. Paste that in and modify it until it is more correctly what I'm trying to get. We're using param 1. We're not going to be actually using taper in quite this way, but we're using this wet calculation. We're going to leave these comments where they are too. Yeah, I'll tell you, Music Anywhere, who has just said likes that I'm taking the snobbery out and making it more intuitive and sounding it less pumped up, colored, and congested. You know, the pumped up, colored, and congested is what I do not like out of modern, like early and mid 70s rock type music. And it's not because it has to be rock type music or all about guitars or anything. I like synthesis, stuff like that from that era as well. But because there's a kind of sonority and richness in tone you can get out of that stuff that was quickly thrown away as soon as people started getting into post 80s heavy processing. Like the pumped up, colored, and congested didn't start with digital. It started with SSL, probably, but just the expansion of mixing and the expansion of the more that you can do with it, which is all well and good. You can do great, crazy things with sound, and that part's cool. But back in the day, you had to do crazy things with sound in such a way that it retained characteristics of the audio that are easily lost. And when you try to take stuff and forcibly manipulate it by overprocessing it into something else, something's lost. So that's when you had 30 million tracks on your giant console, but they all sounded really small, so you had to add more of them. Contrast that to like Led Zeppelin, where Led Zeppelin 2 was mixed on this funky old Trident mixer that didn't even have pan pots. That's how old it was. Led Zepp 2, the sounds were got by doing individual mics and placement of mics and combining mics with other mics in the sound. But they didn't have banks of EQs and processors for everything. So they did the sound getting in this simpler way. And you can do those techniques like I'm continuing to demonstrate in the box. And you can do it for nothing with free open source software in the box. But you have to know what you're doing. You have to choose that rather than choose other things. Because otherwise it's the same as, firstly, if you capture sound and you're not able to capture what you need into the digital audio converter, then you can never get back what you didn't get in the first place. But then also if you immediately mangle and overprocess it in a way that is not the point of the exercise, there's whole genres where that is the point of the exercise. You get into a place of you can't get there from here. And that's why I'm talking about using fewer tracks to make bigger sounds. Anyways, let's get back into this because we are trying to do something. I'm not going to want 8 stages of this. I'm going to want like 3. So let's amend this to have only, well, no, let's change my mind. Let's have 4. That's probably going to be enough. Edit the comments. And then I kind of have to amend all of these things. So you'll bear with me while I do that. This bit at least I can do rather quickly. Done. And again, I know it's going to need to be B, D, so oh, what am I doing? Help, help, I'm being oppressed. There we go. And duet is the last, so we're not going to use these, but this is going to be the form that the final one needs to be. So back to D. I'm just trying to walk through this in a way that I can understand. More will be revealed as far as how this works. Once I have it actually updated, I'll tell you what it does. And this may be the final one, and I may want to skip this one. So we want duet equals, oh, and get param 3 goes up to 8 up here. So what I can do, since I don't actually need it to read that, is the equivalent. There. So now we've got a duet that starts with a 0 to 1. It is the taper control. And oh, Heritage Audio doesn't actually need to send me anything. I've got the things I need from them. I mean, it's like, if I had an endorsement deal with them, it wouldn't be too far off what I ended up with, because I have the MCM and I have the successor. That's my drum bus and like bass and stereo piano or whatever input processor. So yeah. Now where were we at with this? D-wet goes from 0 to 4. So if it's less than 3, it becomes this. If it's between 3 and 4, it becomes this. So what's going on is progressively we are making stuff be either 0 or 1, or the between. And the dry and wet controls it starts with the first one going from 0 to 1. At that point, we're always using the processing inside there, and the next one has a dry wet that goes from 0 to 1. And then we're always using what's inside these two, and then the next one goes from 0 to 1. That's what this does. It's a successive set of dry wet stages. So this actually kind of makes sense as part of the increment calculation, because that is the speed of decay. But as we're scaling this up, we're also trying to increase the speed of decay. So we're increasing the slope even more rapidly. Bottom line is, does it sound good? And we'll be finding that out. We don't need this. Because here's what we're going to do. We're going to stack these up inside those little dry wet controls. And we're going to look at how that was done, and it's like this. I can straighten this out like this. So what we're going to be doing is trying to do a dry wet inside each of these. And we can also because right now what that's doing is that's just scaling them up bit by bit, so that each time we increase it, it kicks in another scale. And I'll run that, demonstrate it, see what it does. Because here's how this works, is input sample equals input sample times A wet plus dry sample minus 1.0 minus A wet. So how we're going to be changing that is kind of like this. Those things don't exist inside this code. But this is what we're updating. So we don't have any dry sample. The thing that we're keeping the same is speed if it's dry. So what we're actually doing here is this calculation only exists inside this place. I'm thinking so hard I'm gnawing my lips. Sorry about that. So speed divide equals increment is smaller. A wet is either smaller or larger. And if A wet is next to nothing, if it's like 0, then speed equals speed times itself. So if I copy this over into its relevant places and update them, I will have the finished algorithm for making this work. We just have to update B, C, and D in all these places. B, C, and D. And since we have one calculation, we don't even need the brackets. And this is not going to change for a stereo plugin like a VST. So this can end up being, oh, I have missed one. D. So one side effect of this is that our simplest form is to have speed always have at least some decay. So technically that's 5 levels of this. Because if we don't have that there, then when we set it to 0, nothing's going to happen. It will not decay at all. In fact, I can demonstrate that for you. Let's do that, and I'll show you. We don't need hold to be here any longer. We need this to be off, and see. Here's our orbit kick, here's our decay. Very aggressive. Interestingly, it's dropping it for some reason, so that's weird. I'm really not sure why it's recalculating. It should go to a high frequency and stay there, but go figure. So we have a very slow decay. Maybe we can live with that. Maybe that actually works, kind of. We drop onset freak, and it's not actually useful. Okay, there we go. So that's what was causing that to happen. And hear how the pitch is going down linearly? As we start adding more layers of this speed divided equals increment, it's going to start doing more of a taper. Up to a really extreme taper. and a super extreme taper. So if we bring threshold back up again, maybe not quite that high. Let's work on the threshold a little bit too. It's being frustrating. So we can make that threshold kick in a lot sooner. You can crank it all the way up and then have it almost never trigger, all the way to like full on 0. I'm thinking about how this is all going to work. I feel like maybe I'm trying to figure out how I want to scale this. As I've got it going up to a super high frequency, as you apply things, like with this onset frequency, that's going to scale everything now, not just where it kicks in. Now let's see what that did. Previously I had it at a fixed 0.1. So we're going to see how this guy works now that I've changed that. Like sometimes the way this kind of thing works, like the way I work with these things, is my ability to talk deteriorates radically as I dive into more and more complicated stuff. Okay, that's extreme. So if I have threshold very low, we've got it where it fairly often kicks in, and I've got a position in the middle where it's perhaps too wide of a range, but that's fine. You can still hear a kind of chiff in there, and that's something that I actually need to work on, but I can hear it activating multiple times as it starts. And if we slow it way down, we can typically hear the little bit of the scrunch sometimes. And our slowest kick goes down very quickly and very short. It's a real I'm still trying to figure out whether I can scale this in a different way. I'm not convinced I'm getting the taper I was looking for. Although I don't like how quick that is. And we've not touched gain, friction, or envelope. And that's important. Excuse me, I'm going to throw another log on the fire. I've been so busily working on all of this. So you can come along with me over here. It's cold in Vermont, so I like to keep this going. I have a nice flat log that'll do nicely for this state of the fire, which is a whole bunch of coals in here, a whole bunch of charcoal in here. Mix up a little bit. And welder's gloves, these are. There we have, let there be flames. I said let there be flames. There we go. Alrighty. Just in case you wondered, there we are. Back to Airwindows Studio. And my headphones and the drums that are still happening. They're sort of happening. And back to the coding screen. So one thing that concerns me is I have a lot of these in such a way where I'm multiple triggering a lot. I don't think that is good. I would like to have it not do that, so what I'm thinking is position plus equals speed times onset frequency seems okay, but this bit up here is not exactly what I had in mind. This is the part that is maybe not working for me. So if input sample is larger than speed equals input sample times onset frequency, that's what's causing this. Let's see what we get if we check for no point copying that. If it's larger than the threshold and larger than speed times onset frequency, it equals speed times onset frequency. This is what was causing some of the scruffy noises I was getting. Now, speed has to be equal to input sample times onset frequency because that's what sets up the initial speed, that's the initial pitch. It has to be able to go to smaller numbers. I can't just have it be like equals input sample and go from there. It has to be able to go to a smaller number, but let's just see what we got then. And that's actually applying onset frequency twice. Let's tighten up that math while we're at it. Since I have it tightened up over here, might loosen that up later. We'll build another, listen to it and see whether I'm doing any progress with that scruff noise, because it's creating a scruff noise. And I'm going to do about another half an hour or so of streaming. Threshold down. So it's always active when I do this. That's a high pitch noise. Okay, we still got this scruffy noise. I'm concerned about that. I think this may be the way that I'm interacting with envelope. And I'm pretty sure what's going on here is envelope was all about me being able to cut stuff off. So dry wet, no longer relevant. Speed, increment, may or may not be doing what I wanted it to do. I'm now thinking about what I can do with this. First of all, I wonder whether I can make this sort of self-referential. What happens if increment is a really tiny thing, but it is always over 1? Speed divided equal by something that is always over 1. I'm trying to figure out whether I can, like, if it was speed divided by speed, it would always go to 1 immediately. So having an increased taper involves having more or less of this nonlinearity, whereas if it's being divided by a number that is slightly more than 1, it's always going to be that linear pitch drop that I'm trying to get away from. However, if it was divided by speed, then no matter what it started at, it would always be like a vertical wall, boom, and then done. I'm looking towards getting a different taper that is not the linear pitch ramp, also not a vertical wall, but some combination thereof. So what I need to do is see what I get out of increment plus, always plus, so it can never be minus, otherwise it'd be divided by, like, it would be blowing up. So the bigger this, the smaller I make speed, the less factor it will have. We're no longer doing dwat of anything. But we're calculating it. And it's going to go from 0 to 1. And it's going to kick in if we have it turned all the way up, so I'll just use that. Because I have it there to use. So what this should do, let's exaggerate it. Increment plus what's inside here is going to be 0 anytime dwet is 0, which is some of the time. So it will be speed divided by equals increment, which means it will not have much of an effect. But as d approaches 1, it's going to be speed divided by increment plus a factor of what speed is. And that will make it closer to the instant drop-off, so that might get me the taper I wanted. Let's find out. We're going to get as far as we can in this last half hour, or slightly less, because I'm going to be real determined about, like, making myself stop. If I don't do that, I end up doing these marathon coding sessions, and it's all very exciting, but I'll burn out, so I can't be doing that. It's not the same when it is on stream. And what have we got? So that sets this up. Oh, wait, this is stacked upon decay. I can't use this. Or can I? Let's fool with it a little more. That was stacked upon parameter 1. Let's stack it upon parameter 6 instead. And then let's get all this stuff out of here because I think I can do this a different way. Boy. Let's go back to taper. There, now none of that's doing anything. And onset freak is the one that is getting affected here. And let's ramp this right up, okay? Back we go. Remember, I have a taper which has been a linear drop off. And I'm trying to make it be a exponential taper. Dropping down like that. So let's see what we got. I don't remember whether decay is doing anything. I think it is. Okay. Decay now no longer matters very much, but it still does. Hear how we have this frequency in here? And below this frequency, it does not activate. Decay should be taking it and speeding the decay even more, but we've already got the decay quite fast indeed. So let's change that. Increment is the base speed. That's how far it falls away, but it doesn't really do all that much, really. On the other hand, taper is doing a lot, so what if it doesn't do nearly as much as that? What if? And I'm still working on some of this. So if input sample is larger than speed, and that's happening too often, we want to kick up speed more. So if input sample is larger than speed times onset frequency times 0.5, it kicks us up to a higher level, at which point it's definitely not going to be larger than, well, hang on, did I just do it that way or did I do it oppositely? That might do it. Bear with me. Not articulating this stuff very well, but trying to do the thing for another 15 minutes or so. This is the point where we accelerate, take off into outer space with orbit kick. Back to drum kit mono. Now what do we got? Keep selecting effect stack. I should not do that. Interesting. What do we got? Okay, very good. We got a decay. Onset frequency is very fussy. And it's really not capable of kicking in at all, so let's change that again. On the other hand, I feel like maybe I've got the scruffy noise situation solved. I added 2 zeros, let's add just 1. And let's get rid of all this dry wet stuff. I'm almost certain that this taper thing is going to work. Unless, no, I think I can make it work all by itself. Always like it when I can do stuff in these dense little clusters of interrelated variables. It's when stuff gets cool. Everything kind of affects everything else, and it makes a really organic sound. Let's see if that is happening. What do we got? So onset freak being like this, I'm looking to have this act like an actual kick drum. So I'm wanting to have the high frequency attack, but then for it to fall away real fast. And then as you drop it down, we're getting some scruffy noises, maybe not quite as much. Threshold can be used. See how this is low down? It's acting like a drum. We're still not tuning it very effectively yet, but it has this cutoff in here. And up here, we're not getting away from that high frequency anywhere near fast enough, so we're going to take it by another order of magnitude. And speed, let's take 2 zeros away and see how effectively we can make this work. How aggressive can we get with this and still have it do something? Do we have any decay left at all? That's the question. Because in theory, it would be nice if we did. Okay, that was too much. Remember how I had a noise down here? But as I increased it up, it would go doo, doo. Well, now it's fading off so fast that it's going down to the subsonics quicker than I needed to. I needed to hang on a little bit more, and that's the opposite of what it was doing before. So I have the zone, and you know what that means? A zone variable. That means we can get another knob in here and dial in the behavior we want. So that goes from 0 to 1. 1 is too much, 0 is too small. So zone speed time zone times taper. Might not even need taper to be in there anymore. Very possible, because that's related. Well, no, it's related to onset frequency, and that will be relevant. So maybe we do still want taper in there. Yep. Do not show on thingy. Remote from sidebar. Thank you. Boop. Getting into the final stretch of today's crunching on this stuff. That's going to be pretty exciting. Now what do we got? There with 0 zone. That is linear. That's just a linear drop. But as we increase zone, which is control 6, there we go. And it almost immediately goes to where that's too much. But check it out. If we dial a attack. And the nice thing about it is that it is related to, and let's just adjust that again. We've still not touched envelope. We've still not touched the way that we're cutting off. 0.035 times 100. So if it's times 10, it will be 0.3, which is a little more manageable as far as adjusting this. And that's what we're going to do. Now have envelope a little bit more controlled. And our cube root is what we use to apply that. Friction is a very small number. I'm not sure whether that's even really working very well for me. Don't remember what friction's really doing very much. Gain has to be very tiny. So let's fuss it. Well, let's make it so we have to crank it fully. We will find out what this needs to be. Back into the breach. And what do we got? Firstly, we can't hear it until we turn gain up. And then there was something else we also have to change to. What was it? Envelope? Envelope. So this is going to be our subsonic frequency. There's our decay. We can start with very slow. Excuse me. Did I change friction? I guess we'll find out. Oh yeah, I changed this. And there we go. Now we have something where it's starting to behave in a more useful, interesting way. We can have it decay be quite slow, or I mean quick, or slow. Threshold can do things. That's aggressive. Oh, and we can make a bit of a noise. And we'll find a setting where it is too small. We got subsonic frequencies going in here. I just don't have them turned up very loud. Increasing envelope increases the depth in which we can go into the subs. Decay is controlling our linear drop-off. So at 0, only onset frequency is doing anything. So decay can make this drop off faster. envelope is not going to retain all of these controls, so we've got to simplify that, possibly remove it. And onset frequency is now serving as a attack, the highest frequency attack that we have. And then if we have envelope too high, there's this sort of lingering thump in here. And we can tighten up the bass by making envelope smaller. We can slow down decay, have it linger a little more. And what were we doing with friction after all? Ooh. This is another loudness factor, isn't it? This is going to have some effect over how much our super lows can come through. So that's probably not going to end up being a controllable slider. We've got to tune it to fit it in. Fooling around and doing stuff. Here's our speed of attack. Slow. To quick. Alrighty, so let's make some notes and then say good day. I'm going to call this zone. And then quickly make some comments here. So more spray for bass. 14. Just gain. Let's move this down here. Higher in frequency attack or exponential fall off. Trigger threshold. Smaller, steeper sub-bass swing. And what did we have for envelope? What was that doing? Let's remind ourselves. Yeah. Higher for envelope is allowing it to go into the subs more before cutting it off with a gate. And that is what these controls do. Noting, of course, that and we've got zone, which is, I've labeled now. Let's call it max exponentiality. That's a cool name, right? Call a guy max exponentiality. I'm thinking that is going to be good enough for today. May come back to this next week, perhaps, because that's some progress, and I've got things labeled nicely now. Sometimes it is time to just do work on the thing and see how much you can make out of it. So on that note, what I will do is bid you good day for the day. I'll catch up with you later. I'll have another plugin for next weekend, and we'll have another video coming out. I don't know exactly what I'm going to do. I'll pick something. It's not going to be OrbitKick, I don't think, but it could be any number of things, like, C-strip, Paf Nutty that will work in rack. There's a variety of things that it could be. I also have a version of Chamber that could come out that blurs between Chamber and like a diffuse straight slapback echo. We'll see. Anyways, I will talk to you folks later.